Since the first powered aircraft took to the skies in the start of the 20th century, not only did it revolutionize our means of travel, but it also changed human society more than the invention of the wheel ever could. It allowed human beings to achieve the dream of flight and provided us the vision to see higher than the skies we now are able to soar. And as the 21st century keeps churning out remarkable technology advancements, an innovation is set to yet again reform the aviation industry as we know it. In today's video, we're taking a look at how electric planes will revolutionize aviation. Before we jump into it, you know the routine. Thumbs up, share, subscribe, and notification bell. In the world of electric-powered computers, mobile phones, gadgets, and even cars, it's quite inevitable to see a future where airplanes would be powered in the same way, especially in a worldwide industry that burns almost 800 million gallons of fuel every day by airplanes, and across for an increase of almost 90% in greenhouse gas emissions in the last 20 years. It's definitely time to opt for more sustainable solutions. Jet airliners contribute to a significant part of climate change through unrelenting fossil fuel combustion producing aircraft engine gases and particulates, which only add to the growing environmental concerns and global impact. Despite becoming up to 70% more fuel efficient in the last 5 decades, the aviation industry still contributes to the rising overall carbon emission due to the fact that the volume of air travel has also significantly increased. By 2020, aviation emissions were 70% higher than 2005 and could reach up to 300% by 2050, as states and governments tighten belts further in order to reduce our total carbon emission, leading to vast regulations through all sectors of society and industries. The aviation industry seeks to align with already known solutions towards attaining a more beneficial effect. A key to all this, just like the automobile industry, is a radical shift towards electric power, who worked on the prototypes for World War I. Developments to further these concepts would eventually bow out due to the rise of petroleum-powered machines. And as the decades would roll by, electric-powered aircrafts were reduced to prototype models and unmanned aerial vehicles. At the end of the 20th century, technologies would eventually start developing airworthy electric-powered aircraft vehicles that were geared to be commercially available. Many of the technologies have geared towards utilizing batteries, solar cells, ultracapacitors, beamed from a ground source towards initiating mechanisms of improving aviation technologies. In the decade, there have been numerous strides when it comes to these innovations, from flights that would take 1,000 kilometers or less to electric and hybrid electric propulsion systems that have provided promising results. Many companies are now pushing forward towards developing the technology for this goal. Electric aviation startups have sprouted in numerous sites around the world, namely in the USA, Israel, Germany, and other parts of Eastern Europe. From the early two-man flights in 2011, which saw a two-seater aircraft developed by engineers from the University of Stuttgart in Germany, achieving venerable heights of potential as it climbed the French Alps of more than 200,000 feet in under 2 minutes and reached speeds of 142 miles per hour, flew non-stop for 300 miles as it burned no fuel and emitted practically zero emissions. The concept of batteries allowing us to power the most advanced plane will be as common as the idea of batteries powering the most advanced cars, which we already have in abundance today. Another great feat was achieved in 2016, when a solar-powered aircraft, the Solar Impulse 2, completed an epic and historic around-the-world journey powered solely by the sun, offering yet another challenge to the aviation industry towards massive and more sustainable innovations. And while ultralight airplanes with experimental designs might seem like the reality for alternative power planes, many industrial pillars are vastly competing to deliver the first commercial plane that would revolutionize the industry. The EFAN-X project, involving giants such as Airbus, Rolls-Royce, and Siemens, have teamed up to develop this hybrid electric propulsion flight demonstrator, with aims of transforming a 100-capacity BAE-146 aircraft into a plane driven by 2-megawatt electric motors. Boeing engineers have created the Sugar Volt concept plane, which aims to combine electricity and fuel to power flight, quite like how a hybrid car does. Unfortunately, we may not be seeing these results anytime soon, as this evolution has been said to be technologically available by the 2030s, with expectations of more seated commercial flights well into 2050. And as the cost of the aviation industry, both financially and environmentally, surely increase, main aircraft engine manufacturers continue to invest heavily to improve existing engine technology. Developers continue to innovate and invent suitable solutions that could literally carry the industry into the next century. Benefits. The technological advances in electric-powered flight today will not only make the act of flying cheaper for the people, it also promises to change how the aeronautics industry impacts global environment. Currently, The airplane we have flying around the globe release more than 500 million tons of carbon dioxide into the atmosphere each year and represent a significant contribution to climate change. Electric flight replaces petrochemical consumption with cleaner, battery-powered electricity. The quicker the industry moves towards more sustainable solutions, the sooner we can reverse the ongoing trend of tripling emissions by 2050. To represent this to a single person who flies round-trip from New York to London, that travel alone approximately generates the same greenhouse gas emissions as heating up that person's entire residence home for one whole year. There would also be significant reduction when it comes to operational costs to airplanes should the shift to electric be fully implemented. While the upfront cost of building one is similar to that of an ordinary plane, the electric version can offer up to 70% less when it comes to operation, with the electric plane requiring no fuel and much less maintenance. A cascade of this cost reduction would also mean a significant cut to ticket prices for the public. Aside from the option of much cheaper flights, airplanes can be serviced in places where huge commercial planes could not fly. The move towards electric planes may see a resurgence of thousands of regional airports that airlines currently aren't using. The shift towards smaller battery-powered planes that allow more flexibility in terms of airline routes is inevitable. The challenge. Still, the biggest challenge in order for electric flight to really take off and become mainstream, especially in commercial markets, is better batteries. Lithium-ion batteries, which currently power most of our gadgets and electric cars, is still inadequate for the demand of aviation power. The next-generation technology batteries need to deliver quite the demand of power, while needing to be lightweight and smaller and totally much safer. However, it's still important to note that with the huge strides of technological advancements in our current society, we could project the possibility of meeting this demand, even well before the expected 30 to 50 years in the future, opening the skies and the planet to a more suitable, sustainable solution to air travel. What do you think about how electric planes will revolutionize aviation? We'd love to hear what you think about them by commenting down below. Don't forget to like, share, subscribe, and ring that notification bell